Morning! You're watching STV, Spangler Television. Just kidding, that's lame. But you are watching a video on the next section in our book, and this is a normal day, normal video, normal homework. This will be on your quiz on Friday, so do take notes and do the assignment, and expect this to come up on your quiz. So we're just learning a little bit more about derivatives today. Specifically one more rule that you can use for derivatives. So before we learn that, I want to just quick review all the ways that right now we know to find derivatives. So we've got a long way and a short way. We'll start with the long way, which we haven't done in a long time, and really I won't ask you to do much anymore, but if I were to ask you to find the derivative of the long way, what I mean is I would say use the definition of the derivative to find the derivative. Definition of the derivative. The definition of the derivative, the long way, that's when you find the limit as h is approaching 0 of f of x plus h minus f of x over h, and that's the really messy, annoying way to find it. Part of knowing that is knowing, okay, this way sucks, so that's why I want to know all the rules. So let's go through the rules we know right now for the short cuts. We started off basically with your basic power rule. Which tells us that when you take the derivative of a variable with a power, you can put the power in front as a coefficient, take the variable, and then subtract 1 from the exponent. That's your basic power rule. We also know the sum difference rule. That rule, if you don't know the name for it, that's the one that says that when we have the derivative of multiple things adding and subtracting together, we're allowed to take the derivative separately. So if you had the derivative of some function plus another function, this is what allows us to split them up and find the derivative of the first term plus the derivative of the second term, and basically take the parts of the function and find separate derivatives. That's the sum difference rule, and it works for whether it's a sum or a difference. That's what's called that. We know the product rule now. This is that rule that says if you have the derivative of some function f times g, then its derivative is equal to, put it down here, the first function times the derivative of the second plus the second function times the derivative of the first. And if these are things that you don't quite have memorized yet, specifically product rule and quotient rule, then that's something you want to work on between now and Friday. The quotient rule, which we've been doing like nonstop lately. If you've got the derivative of one function divided by another function, we know that we are allowed to take the derivative of the denominator, it's bottom times derivative of the top, minus top times derivative of the bottom. And don't forget the bottom part squared, g of x squared. Okay, so you have those already, but I wanted you to have them all in one place. These are all the ways we know to find derivatives up until this point. The long way and our basic shortcuts. So I'm going to ask you to consider one problem here. Okay, so based on all the stuff that we've learned up until this point, if I gave you that problem and I said, okay, fine, let's differentiate that. Let's find the derivative. What I would expect to go through your head would be, oh, that's a power. I can use the power rule. So this is a common mistake. Your probably first idea is going to be, let's use the power rule, multiply the 3, and we'll say that f prime of x is 3 times 2x minus 5 to the second. That would be my first instinct if I hadn't learned anything else. It turns out that's not the correct derivative. If you were to do the long way, you would not get this. So this is not true. The power rule alone does not work here. Does not. And make sure you know that because that's an easy mistake to make. Okay, so you have a couple of options based on what you know to this point. And I have them written out. I don't need you to do this. I want you to show you basically that you don't want to do all this work. So we could try expanding and using the power rule. So you can't use the power rule as is, but if you had it all multiplied out, you could. Then you could do the sum difference rule and use the power rule. So what I've done here is I started out using Pascal's triangle and expanding this polynomial. And I stopped because I could tell this is going to take a long time, and I know that there's another way to do it. So if you can tell that this is going to take a lot of work, and then once I expanded it, then I would still have to do the power rule for each term, and that's going to get really tedious. Okay. Another option is we could use the product rule. Product rule only works for 2 functions though, so if I were to use the product rule, I'd write it out as 3 separate functions, and then I'd combine 2 of them. So now I have 2 functions. So then, based on that, yeah, I could use the product rule. I did the first function times the derivative of the second, and the second function times the derivative of the derivative of the first times the second function. And then there'd be simplifying to do here. Neither one of those is quick. There's actually a quick way to do this, and that's our lesson for today. It's called the extended power rule. Expanded. I wrote the wrong title in the notes. No, it's the extended power rule. Okay, extended power rule says that if you're taking the derivative of something, basically the reason we're not allowed to do the power rule here is because you've got more than just x inside. So if it's just x with a power on it, then you can use the power rule. But if you have x adding or subtracting with something or multiplying by something, then there's really an entire another function within those parentheses, and that function needs to be taken into account. So if you've got the derivative of a function, an entire function, not just an x, to a power, then yeah, you can use the power rule to start. So you can multiply the k in front of your function, and then subtract 1 from your exponent. That would be this step. Except that it turns out that's not all that's involved. You have to do the second part where you take the derivative of what's inside and add that into your derivative. So let's go through what we have written here. This is just the derivative of the outside. So it's like you're ignoring the inside of the parentheses and taking the derivative of the whole parentheses, like of the outside. And this is just totally ignoring the inside, leaving it how it is. This is just the derivative of what's inside the parentheses, ignoring the outside. Okay, a couple of examples. of how you could use this to make your life much easier. Okay, so if I said differentiate that, obviously, I mean find the derivative. So you could think of it as a quotient, but things are, if you've got a 1 on top, you can change this to not being a fraction anymore. I mean, if it's a 1 on top, you could change this to a negative exponent, making it no longer a fraction. So really, this is 3x plus 8 to the negative second. Actually, this would still be regular f of x. We haven't found the derivative yet. Okay, so I would change it to what it actually is 3x plus 8 to the negative second, because then you can use the power rule. And then you don't have to mess with the quotient rule at all. Okay, so the extended power rule says that I'm allowed to do the power rule. So my exponent is negative 2. Multiply that times what's, well, the power rule would be negative 2 in front. Don't worry about the inside, it stays the same right now. Think of that as like your x, and then subtract 1 from my exponent. And then I would multiply that. This is the second part, times the derivative of the inside. So the derivative of the inside here would just be 3. 3, the 8 goes away, so I just get a 3. And then I can simplify that. So negative 2 times 3x plus 8 to the negative third times 3. And then I just simplify completely. I'm going to move this back to the bottom. So in this case, I am going to get rid of the negative exponent. But just know that this 2 is not connected. It's just multiplying. So the negative 2 and the 3 stay on top together, multiply together. And I can move the 3x plus 8 to the bottom. And that would be my derivative, which is way fewer steps than if you were to multiply this out and get it squared and then use the quotient rule. This is an example of using just the power rule, or extended power rule, combined with the power rule. Here's another one. And feel free, as I'm doing this, because it's a video, to pause it and try to work on it your own, and then start it again, whatever you want to do. Okay, this one would be a nasty one to do without this rule. Okay, that's a 3, and that's also a 3. Okay, so we've got a lot going on here to find the derivative, and the worst way you could possibly do this would be to actually expand this whole thing, or this whole thing, to the fourth. That would take you forever. So this is where the extended power rule really saves time. So we're going to be using 2 rules here, actually, because we've got a difference. So some difference rule says we're allowed to find the derivative of this, and then find the derivative of this separately, and then just subtract them. The derivative of a difference is the difference of the derivatives. So I'm going to start with this first part. So for just that, I can do the power rule to start. 3 in front, 1 plus x to the third. Subtract the exponent by 1. But then the extended power rule says I have to add in also the derivative of the inside, and the derivative of the inside here would be 3x squared. The 1 goes away. Okay, that's just this part. So I've just found the derivative of the first term. Now I'm subtracting the derivative of the second term. So again, I'm going to use the extended power rule here. 4, 2 plus 8 to the 8th, x to the 8th. Subtract 1 from the exponent and multiply by the derivative of the middle, of the inside. Multiplying by the derivative of the inside is the part that everybody always forgets. So don't forget that if you've got multiple things in there, you need the derivative of the x, or the inside. And then you can simplify. So this 3 and this 3 can multiply, and I'm going to put the x squared in front. So I'll have 9x squared. I'll have 1 plus x to the third to the second, and 8 times 4 is 32. X to the 7th, I'll bring that to the front, and 2 plus x to the 8th to the 3rd. And I'm going to leave it there. This is where I would ask you for questions, but you can't talk to me, so hold your questions. Okay, here's a really nasty one. I would encourage you to try this by yourself before watching me do it. All right, if I wanted to differentiate this, I've got a couple of problems. A, it's a product. You're going to have to use the product rule. And B, it's got multiple things inside. I mean, I can't just do a simple power rule. I need the extended power rule. So I have two whole functions being raised to exponents. So you're going to be using a combination here of the product rule and the extended power rule. So by the way, this was f of x. This is down here. We started finding f prime of x. This is the derivative. Okay, so if I want the derivative, I'm going to start with, power rule says I start with my first function as is. So I'm starting with my first function as is. And I'm going to use a bracket because the derivative of my second function comes next, and that's going to be multiple things. So derivative of my second function, I use the extended power rule. 5 times 2x plus 1. Subtract 1 from the exponent, becomes a 4. And I need to include the derivative of the inside, which would be 2. So just to clarify what I have here, this is my first function. I'm using f of x. That refers to this f of x. I should have used a different letter. Actually, let's call that g. Let's call first function g and second function h. So it's my first function times the derivative of my second, using the extended power rule. Adding that to my second function, as is, times the derivative of my first function. And that will require, again, the extended power rule. So this was h of x, and this will be the derivative of my first function. So extended power rule, 7 times 3x minus 1. Subtract 1 from the exponent, and I need to multiply by, again, the derivative of the inside, b3. And then from here, you're going to simplify. Take a second and see how if you can simplify that on your own. I think you're going to see that you might need some guidance from what simplified would look like here. So all of this can now multiply. I can take out the brackets at this point. 5 times 2, I put the coefficient in front, 10. I'm going to have 3x minus 1 to the 7th, and 2x plus 1 to the 4th here. It's adding to 7 times 3 is 21. I can put that in front. And 2x plus 1 to the 5th, 3x minus 1 to the 6th. Okay, so it turns out that's not actually simplified because this can factor. I'll show you what I mean by that. I've got common factors here. Here's a common factor. This big long term has a 3x minus 1, a bunch of them, and so does this long term. It has 6 of them. This one has 7. So I'm going to factor out that common factor that they have. I can take out a 3x minus 1, and I can actually take out 6 of them because they each have at least 6. What other common factors do we have? Well, both of these big long terms have a 2x plus 1. They both have a bunch of them. So I'm going to take out 4 2x plus 1s from each big long term. And then I'm going to write what I have left over after I take out both of those things. So if I took out from this long term 6 3x minus 1s, I've now got 10 left over, and I still have those 4 2x plus 1s. Oh, and I have a 3x minus 1 left because I only took out 6 of them, and there were 7. So I have 3x minus 1, and then I still have the 4 scratch that. Let me erase that. I took out 4 2x plus 1, so those are all gone. I took out 6 of those, so there's the 10 left and 1 of those 3x minus 1s. And then I've got plus. I didn't take out the 21, that's still there. And then I took out 6 3x minus 1, so that whole thing right there is gone. And I took out 4 2x plus 1, so then I have 1 2x plus 1 left over. Okay, how is this better? Well, you now took out these factors, and then each of these, there's only 1 left over, so you can multiply all this together and get it down to 3 nice factors rather than multiple terms here. 3x minus 1 to the 6th, 2x plus 1 to the 4th. I'm going to make these parentheses now because I'm going to distribute. 30x minus 10 plus 42x plus 21, and then I can combine my like terms. We'll make 72x plus 11, and now it's all factored rather than multiple adding terms. And that's the extended power rule. So good luck with your assignment. I will see you tomorrow.